Evenings allow you to forget the bitter worries of the day and get ready for the sweet dreams of night. A very good evening to one and all gathered here. Thank you all for finding time and visiting today's webinar. Our today topic is Research in Education Part 12, Net Preparatory Course. Now it's the time to introduce our resource person. So I would like to welcome Mrs. L. Divya, Research Scholar in TNTU and working in Mangekarsi College of Education, to welcome our resource person. Divya ma'am.
Yes ma'am. Thank you.
Okay, once again ma'am. Okay, Divya ma'am, you can proceed now.
Okay ma'am. Good evening to everyone present here. Thank you to all for joining with us. The common facts of today's are the products of yesterday's research. Yes, it's my privilege to welcome you all for the today's national level webinar on Research in Education Part 12, Net Preparatory Course. First of all, I would like to express my gratitude to our Vice Chancellor Sir, Registrar Sir, Controller Sir, and all HODs and all Assistant Professors who are all the supports of TNTU. Now, it's my great pleasure and honor to welcome our eminent resource person, Dr.N.Ramakrishnan Sir, Member Syndicate, Professor and Head, Department of Educational Technology, Tamilnadu Teacher Education University. I'm so proud and happy to welcome you in this occasion. We welcome you, sir.
Thank you.
Last but not least, I would like to welcome and extend my thanks to all the principals, teacher educators, student teachers from various colleges. Once again, I welcome you all for this section. Now this section is handed over to our resource person, Dr.N.Ramakrishnan Sir. Sir, this time is yours, sir.
Okay, thank you.
Thank you, sir.
Good evening, students. Good evening, participants. I'm very happy to be here with you in this great evening. And yesterday we had a wonderful session, 100th session of our Center for Civil Services and TNPSC coaching. We had a wonderful motivation speech by Miss Purana Sundari IAS, and we are all motivated and we are all drenched in her story and her life story. And in this, this is 101st program, Research in Education. Already we have seen up to part 11. This is part 12, and what we are going to see in this, we are going to see inferential data analysis, use and interpretation of statistical techniques, correlation, t-test, z-test, ANOVA, chi-square. That's all. And I hope I could finish all these things within the time frame of 1 hour. And let us start. Let us start our discussion on these topics. Inferential data analysis. Once again, I repeat: use and interpretation of statistical techniques, correlation, t-test, z-test, ANOVA, chi-square. Now let us see first inferential analysis. What do you mean by inferential data analysis? Actually, there are two types of analysis. One is descriptive analysis, another one is inferential data analysis. Descriptive data analysis is nothing but a story of a person, story of a case, story of an incident, story of a problem, and that we are just narrating. And I have already told you when we are discussing about qualitative data analysis, and we used to make a lot of notes about a particular person. Suppose I have given you an animal. You just observe that animal and record its behavior. I have given to you that you will be sitting before that animal, not directly, but the animal will be only in cage, and you will be directing, they will be recording the behavior of that animal. Morning, how does it take food, or what are the behaviors it exhibits, and what kind of changes it shows. And when you are asked to say about that animal, you will be giving a detailed explanation about that animal, because you might have observed her for about, might have observed about that animal for about 1 week or 2 weeks. And when you are observing, you will make a diary of that animal, and that is known as descriptive analysis. But here in inferential data analysis, we don't do like that. And here the population and the population is population characters. Now we have a population data. We have to get interpretation. We have to give interpretation about the population characteristics or population, any type of behavior or any type of behavior which we want to measure. That for that we will take population. We will take sample from the population. Suppose I'll give an example. You wanted to study the eating behavior of people during Corona period, and that we will study, and that you may take you may take your locality. Maybe you are residing in a municipality or residing in a corporation, and you can't collect data from all the people who are in your municipality or in your corporation. And for that, what you will do, you will go with a sample. You will follow a sampling technique, which will be the right type of sample that I will select. And after taking a sample of people from your municipality, that you will be giving a questionnaire or something like that regarding the eating behavior of these persons at home during this Corona period, and we will be listing out a lot of things related to eating behavior, and you will be collecting data. After collecting data, you will do some analysis. You will give some numbers to those data, and those numbers will be calculated. Those numbers will be given statistical treatment. Giving an opinion about that particular population. You will give an opinion about that population, and that population, that is known as inferential statistics. That means we get some inferences from the population, not entire population we are taking. We are taking only a sample, and that sample we collect data, we analyze and we interpret that data, and we give some inferences from the data that we have obtained, and we give inferences about that population to the, suppose we are reading behavior study may be of helpful to the government to think about lockdown relaxation or lockdown, making more stringent measures of lockdown, and that type of thing will be happening. That is why inferential studies. Now I hope you all have understood. You could have understood these two examples. That one, I gave one example, that is you are observing an animal in a cage and you are keeping a diary and recording all the events, that is known as descriptive statistics. But in your locality, you are taking a survey. You are taking a survey of how you are taking a study on eating behavior of people in your locality, and you are doing some sampling technique, and you are collecting data, counting it, and you are doing some statistical analysis, and based on the statistical analysis, you are getting some conclusions. Based on the conclusions that you have derived from the sample, you are giving inferences about the population characteristics. So this is how people eat in the Corona period. This kind of solution, this kind of conclusion will be finding you will be giving about the entire population. That is known as inferential statistics. Now I read this slide for your sake. The branch of statistics is nothing but the branch of mathematics that transforms data into useful information for decision makers. Number one, descriptive statistics, collecting, summarizing, and describing data. Inferential statistics, drawing conclusions and or making decisions concerning a population based only on sample data. Now let me see another example of the difference between descriptive statistics and inferential statistics. Descriptive statistics works with a smaller data set. Like an animal, we can collect the information about a few people only. For the entire population, we cannot make any study like in this descriptive statistics. But in inferential, it can be worked out with a large data set. It works with a large data set. And then just I gave example, municipality, corporation. Maybe 12 million people are there, and then 12 lakh, 1 crore or 1 crore people may be there in the corporation. And you are taking a sample, and based on the sample observation, you are giving some prediction about the entire population. That is possible in inferential statistics. But whereas in descriptive statistics, you can select only a few people whom you can observe, and you can give some solutions. That's all. And this in descriptive statistics process is simpler to do But inferential statistics process is more complex as we have to decide on the best sampling techniques. In descriptive statistics, results obtained represent the entire data set because we don't take any sample, entire data set. But inferential statistics, results obtained represent a portion of the population but can be used to deduce information from the entire population with some amount of uncertainty. But there are also some uncertainty because there may be sampling error. All these things are possible in inferential statistics. But in descriptive, now you see, in descriptive statistics, error involved is usually less error. Will be because you are selecting only a few people, you are recording all the events, no error, no chance for error. But in inferential statistics, the error, the chances for error is more because and we may take up a sample. That sample may not represent the population. Maybe the sampling technique that we adapted may not be suitable to the population, and the population may be a more heterogeneous population. We cannot make any prediction. I can give you an example. Many surveys are being taken before election, and people are saying that this party will come to power, that party will come to power. But after the election, when the counting starts, and when we see the results are in a different node. Because why is it? Because the population is a heterogeneous population, different age groups, different economic background, different social background, and different cultural background, and different language background. There are so many n number of factors which affect the election process because people decide on different factors based on cost, based on economy, based on good policy, based on so many things. So that's why in the heterogeneous population it is very, very difficult to make a very correct prediction. That's why error is possible in inferential statistics. Inferential analysis use of statistical tests either to test for significant relationships among variables or to find statistical support for the hypothesis. Inferential statistics are numerical values that enable the researcher to draw conclusion about a population. That I have given an example. Population based on the characteristics of a population sample. We are taking only a sample and we are observing, we are collecting data and we are applying statistical technique and we are giving some inferences about the population based on the sample that we have observed, based on the sample that we have studied. This is based on the laws of probability. And I have already told you in many of my classes, and I have told you that, and all statistics totally relies on normal probability curve. And before you are stepping into any type of analysis, for example, most of my students here and here are doing MEd and MPhil, PhD scholars are also here. And before you are making up you are entering into a study analysis, and you should decide what type of statistics you should apply, inferential statistics or descriptive statistics. Why I say that before you are stepping into your data analysis, you should decide what type of things what type of variables you have taken. What variables means research variables. What type of research variables you have taken. Suppose you are saying that study habits. You can assume that study habits definitely it falls under normal probability curve. Why I am saying that it falls under normal probability curve? There may be some extreme people, both positive as well as negative. But the positive side, there may be people who may have regular study habits. There may be people who have not at all any study habit, regular study habits. But there are people who are clustering around the center during the exam time and other times they used to study, and on this and that will be that study behavior. So naturally the study behavior falls under normal probability curve. And can you just like that? You can just think what type of data you are collecting. Suppose you are collecting data regarding number of pens each person is having. Is it fall under normal probability curve? Definitely not, because number of pens, one person may have 2 pens or 3 pens, one may have number of pens, one may even have a pen shop. That's all. So it's n number of things we may have. That is that cannot be placed in the normal probability curve. Once again, I repeat, the normal probability curve is a bell-shaped curve where both ends are infinite, because there are good people, there are very bad people, but most of the people cluster around center. So why I am saying again this, if you take up a study and you see that the research variable that you have taken is applied, can be placed in the normal probability curve or not. If it cannot be placed under normal probability curve, you can go for descriptive analysis. If it can be placed under normal probability curve, you can go for inferential statistics. This is the difference that you have to identify, and after identifying this difference only, you should enter into what type of statistics you should adopt. And you see the difference again. Once again, the difference between descriptive statistics and the inferential statistics is clearly given in this slide. For your sake, I read this slide. Descriptive statistics are numbers that are used to summarize and describe data. The word data refers to the information that has been collected from an experiment, a survey, a historical record, etc. Inferential statistics, whereas the sample is a set of data taken from the population to represent the population. Probability distributions, hypothesis testing, correlation testing, and regression analysis all fall under the category of inferential statistics. See the picture where normal probability curve is placed, a bell-shaped curve. You can see from your mobile phone or your laptop, you can see that inferential statistics is represented in normal probability curve. Then what is the difference between descriptive versus inferential statistics? Descriptive statistics is a method for summarizing data. We can summarize only. We cannot do more than that. Methods for summarizing data. Summaries usually consist of graphs and numerical summaries of the data. Inferential methods of making decisions or predictions about the populations based on sample information. Now let us see this use and interpretation of sampling statistical techniques. Use and interpretation of statistical techniques. And what are the uses of statistical techniques? That statistical methods can be used to find answers to the questions like what kind and how much data need to be collected, how should we organize and summarize the data, how can we analyze the data and draw conclusions from it, how can we assess the strength of the conclusions and evaluate their uncertainty. These are all the uses of data. Use and interpretation of statistical techniques. You can see types of data, data collection, data analysis, examples, advantages, etc. And document review, observation, survey, questionnaire, interviews, probability sampling, quantitative data collection. This is what we can collect. Now let me give concrete, and let me get into this statistical part. Correlation. Let us see correlation. What do you mean by correlation? Correlation refers to a technique. Before I read this slide, I would like to say about correlation. Correlation is a degree and direction of relationship between paired variables. Suppose, what is the? Can I give one example? The eating behavior and the weight of a person. The eating behavior and the weight of a person. And can I ask a question whether these are paired variables or not variables? Eating behavior is one variable, and the weight of a person is also another variable. When these two variables are paired or not paired. Paired means related or not related. It is related. When the eating behavior is more, then definitely it will increase the weight. When the eating behavior is very less, definitely it will decrease the weight. So definitely these two are correlated variables. These two are paired variables. This is we have to find out to what extent there exists a correlation. And the correlation may be a positive correlation, negative correlation, zero correlation. Zero correlation means nothing has happened. It has not at all increased the weight. It has not at all decreased the weight. That is zero correlation. It has increased the weight. That is positive correlation. It has decreased the weight. It is a negative correlation. That's the thing that we have to discuss here. Now see the definition. I read for your sake. Correlation refers to a technique used to measure the relationship between two or more variables. A correlation coefficient is a statistical measure of the degree to which changes to the value of one variable predict changes to the value of another. A correlation can only indicate the presence or absence of a relationship, not the nature of the relationship. Correlation is not causation. Now once again I read, and the correlation is once again I read the slide. Okay. And correlation can only indicate the presence or absence of a relationship, not the nature of the relationship. Correlation is not causation, but correlation coefficient is a statistical measure of the degree to which changes to the value of one variable predict change to the value of another. So naturally, I have given example: eating behavior and the weight loss or weight increase that you can take, and also you can take another number of films you have seen, number of the eyesight, the problem in your eyesight, and then you can say many number of things. Number of times played, spent outdoor, and number of the total marks, the marks scored in exam, and the people and the students who have concentrated more on TV serials, and the score obtained in the monthly exam. So these two are correlated. When there is an increase in one variable like TVBV, definitely there will be a change in another variable, that is marks score in the monthly exam. So these two are related or correlated or not, we have to find out using this correlation technique. Correlation is a statistical tool which shows the relationship between the two variables, in which change in the value of one variable due to change in the value of other variable. And suppose there is a change, I have already given you an example. The change in one variable leads to change in another variable. That is correlation. And what is correlation? The term correlation in its simplest form means connect or to be connected. Is there any connection or not connection? There are no connection. That we have to see. To be more precise, correlation means mutual relations of two or more things or persons. You can take a number of examples and the number of times that you are seeing yourself in mirror, and the response that you are getting from the response you are getting from your opposite sex like that. You can also take that as a correlated one. So because the more that you are concentrating on your makeup, the more you are concentrating on the response that you are getting from the outsiders. That may be a correlated one. Then like that, we can have a lot of correlation. There are many variables. We can give example. For example, the medicines taken and the medicines taken and the cure for that our fever, like that. Many things you can take. Now you see, this is the crude criterion for evaluating the magnitude of correlation. To what extent there is a correlation? To find out that, and there is a crude criterion people have fixed. Now see here coefficient is coming. Your coefficient is coming x and y, x variable and y variable. X variable I give again the variable x as study habit and y as score in exam. Study habits. Now you are seeing and you are collecting data regarding study habits, and you are collecting data regarding scores of students, and you are comparing these using a correlation coefficient formula, and you are getting a result, and the result is below 0.1 like that. That is negligible correlation. There is a negligible correlation. If it is 0.3 like that, it is very low correlation. If it is 0.4 to 0.60, moderate correlation. If it is 0.6 to 0.8, substantial correlation. If it is 0.8 to 1, there is high to very correlation. Actually, the correlation value ranges from -1 to +1. Actually, the correlation value ranges from 0 to 1, 0 to minus. 0 to minus means negative correlation. 0 to +1 means positive correlation. 0 is no correlation. So this is the proved criterion for evaluating correlation. Now see this slide. Correlation coefficient shows strength and direction of correlation. Suppose if it goes towards the direction of +1, goes towards the direction of +1, maybe plus 0.2, 0.3, 0.4, 0.6 like that. And if it is above 0.5, there is a strong correlation between these two variables. If it comes down, that we can say that there is a weak correlation between these two variables. And you can say that in the negative way, and so you can say that it is 0.2 or something like that. And you can say that it is very low correlation. If it goes above -0.7, it is a strong negative correlation. That like that we can interpret correlation coefficient. Now I give this slide as example. Positive correlation implies a direct relationship between two variables. Example: meditation increases level of concentration. Naturally, meditation is the one variable and level of concentration is another variable. When you do meditation, actually it increases your level of concentration. That is, there is a positive correlation. And a relationship between variables. For example, if students missing the most classes get lower grades, the suggestion is that there is a causal relationship between attendance and overall performance. A more number of absenteeism in the class, then definitely the grades will be very low for the students. Suppose if the grades of the students are very low, then you can say that there exists some negative correlation between these two variables. And now see, this is correlation analysis. Even in business transaction, they do correlation analysis. It helps them to find out the exact cost for their sales and let us see this example. The sales manager of copier sales of America has a large sales force throughout the United States and Canada and wants to determine whether there is a relationship between the number of sales calls made in a month, and the number of copiers sold that month. That means the salesperson, they are getting phone calls, the number of calls they have received, and number of copiers they have. Suppose people will be inquiring about copier. That means photocopier or Xerox machine. Now suppose they make a call, and for each, how many calls are turning into sales. This is what they wanted to analyze. And they have selected, the manager selects a random sample of 15 representatives and determines the number of sales calls each representative made last month and the number of copiers sold. Determine. Suppose, for example, you can, if it is very difficult, you can think. Now you can think of a person who sells some like whatever. You can measure Swiggy. Or Swiggy, a number of calls made to Swiggy and a number of sales made. There's just like number of persons who are doing these sales, and you can analyze number of sales calls, and number of calls, number of sales, and you can have a comparison of these two. And if it is a positive correlation, the number of calls are made into sales, and if you get negative correlation, the number of calls doesn't correlate with the selling behavior, and it gives negative correlation. If at all there is no correlation, like that in this picture, there is no correlation between, because the points are scattered, so you cannot predict either goes in positive direction, neither goes in positive direction nor in negative direction. It is scattered. So in that sense, it is zero correlation. There is no correlation at all. So like that, you can find out. It will help you to increase your business, increase your reachability of your business. It is most applied in business also. And you see this positive correlation. The points are clustering around the positive direction. Here in the negative correlation, it is the points are the points are clustering around and the negative side, negative direction. It goes the direction also negative, and they are in negative correlation. Now you see this, if it is in positive correlation, if it is in the negative side, it is a negative correlation. Then when it is scattered, there is no correlation at all. You see, I read for you. This shows that positive correlation. As one variable increases, the other increases. When one increases, the other two should also increase. And this shows that as one variable increases, the other decreases. Now you can see the number of pizzas taken. And the number of now you can say the number of medicines taken, the decrease in your disease level, that you can take. The number of pizzas taken, the total weight increases in your weight. There is a positive correlation. When one variable increases, the other variable decreases, it is negative correlation. When the one variable increases, the other variable too increases, there is positive correlation. And there is no difference, there is no change, no connection between these two variables. There is no correlation. I hope. Now let us step into t-test. What is t-test? T-test is a degree of it's a student distribution. It is known as student t-distribution because it was found out by Gossett. And Gossett at that time, he was working in a Guinness brewery in Dublin. The time that thing is, they should not use the name of the person who found out that test at that time. That is why he used the student t-test. And this is our history. Now let us step into t-test. What is t-test? There are independent t-tests, paired t-tests, and in the independent t-test we have unequal variance and equal variance. And normally we apply t-tests for independent samples because you all MAT and MPhil PhD students, you are all having independent samples, because independent samples you don't have any paired samples. For paired samples it is correlated. For correlation we have a separate formula for correlation t-test. First of all, before stepping into t-test, what is t-test? t-test shows the difference between two variables. I have already told an example in my earlier class that I don't know whether you remember that or not. Suppose class A is having 60 marks as average and class B is having 70 as average. We can easily jump into conclusion that B is higher than A, and based on the average you can say. But in differential test, we do not take not only mean, we do take the standard deviation also. When we take the standard deviation of A with the average of 60, and we take the standard deviation of B with the 80 average, and then we work it out as the independent. These two are independent samples. We work it out. Then we find out there is a difference. The value, calculated value is above, higher than the table value, which we can see in the statistical book in the back side, and for the degrees of freedom. And we can degrees of freedom actually n1 plus n2 minus 2 is the degrees of freedom. For that we will be finding out t value in the statistical book. And if the calculated value is higher than the table value, there exists a difference. If at all there exists difference, generally you can say B is higher than A. If the calculated value is lesser than the table value, you cannot say that there is a difference between A and B. To be very precise, I will give one example. And in your locality, 20 homemakers. So housewives are called as homemakers, and 20 homemakers are using green bar, and 20 homemakers are using a power soap. Like that, you can take these two as the example. And you see number of now you see the performance. You see the performance. It is the best performance, and that is you can count the number of cloths they have washed and the number of cloths washed here. And you can looking at that, you cannot say that there is no difference. There is a difference. Suppose if they have washed class 10 class, they have washed only 6 class. For example, 20 class per bar, and they have washed 30 class per bar. You can say at the face value, you can say that this bar is comparatively better than that bar. That you cannot say, but you have to find out the difference. The number of other people who are also using the same bars, and what is the significant differences that we have to find out. Then if there is a difference, then only you can say that there is a difference between rim bar and power soap, and then you can make a prediction based on the average. If at all, you cannot make any prediction. Again, I say the same example. The students' score is 60, and then the one set of students' score is 60 average. So one set of students' average is 60, another set of students' average is 70. Based on the face value, you cannot say that B is better than A. You have to find out the significant difference, because we have taken only the measures of central See, we have not taken the spread or the dispersion. And if you have taken the spread also, then you can calculate t value. If a t value shows that it is higher than the table value, then naturally there exists a difference. Then only the interpretation of B is better than A is correct. Otherwise, it is not correct. If at all the calculated value is very less, and you cannot, based on these two values, you cannot say that B is better than A. It means both are equal in their performance, because the standard deviation is playing there. Now, to know about this t-test, you ask a number of questions, and I will explain. Okay, and this is paired t-test. Paired t-test. Suppose paired t-test is used for the paired variables, where we can have paired variables that to interpret to get the difference between in the paired from the population to sample that we have taken. We will use paired t-test. This is the formula that normally using for independent samples, and we have also formula for small independent samples. And this is independent sample t-test again. Now let us see z-test. What is the z-test? It is a hypothesis testing procedure based on the z statistic, which assumes that the probability distribution of the events under investigation follows the standard normal curve. If your characteristics that if your variables the variables that you have taken falls under normal probability curve, it is normally distributed, you can go for z-test. If at all it is not falling under normal probability curve, we cannot go for z-test. When to use the z-test? The z-test is a statistical test for the mean of a population. It can be used when n is greater than 30. Suppose when n is greater than 30, or when the population is normally distributed and standard deviation is known, only you can use z-test. Otherwise, you cannot use the z-test. Z-test. For testing the significant difference of between two means of samples, it calculates the probability that the two samples could have drawn from populations of the same mean. Differences arising merely from sampling variability. Assumptions for z-test: population approximately normal or large sample. Sample size must be larger than 30. Data must be quantitative. The variable is assumed to follow normal distribution in the population. If your population, if your characteristics are normally distributed, you can go for z-test. If it is normally distributed, not normally distributed, you cannot go for z-test. This is about z-test. Now let us see ANOVA. What is analysis of variance? Analysis of variance we are employing when we have to find out the difference between two and more variables. Suppose we have got only two variables, male and female, and there is another variable known as transgender. In that time, you cannot use t-test. T-test is used for difference between two variables and two means. And here there are three means. When there are three means, and comparing one mean with the other mean, there are chances for doing type 1 error and type 2 error. That's why when we reject the hypothesis at 0.5 level, if a number of means are more than 3, for example 5, then we may have a chance error of 0.5 for 5 to 0.25. 25% of the sample may go wrong. The 25% of the hypothesis that you have framed may go wrong. So that is why for the sample, for the means more than 2, we are employing analysis of variance. Analysis of variance and is objectives. Understand how analysis of variance is used to test for the equality of 3 or more population means. Understand and use the terms like response variable, a factor, and the treatment in the analysis of variance. Learn how to summarize a feature in the form of another table. And this is an independent sample t-test is when the independent variable has two levels, upper class, lower class, like so here in school. For example, independent variable is here in school, upper class, lower class. Again, one way ANOVA is used when the independent variable has 3 or more levels here in school. Independent variable is here in school. You see the dependent variable freshman, sophomores, juniors, seniors. Sophomores first level. That is so juniors and seniors. First graduates will be known as women. When there are 4 categories, then definitely we have to go for one-way ANOVA because it has more than 2 variables. When to use ANOVA? Analysis of variance is the most commonly used technique for comparing the means of groups of measurement data. There are lots of different experimental designs that can be analyzed with different kinds of ANOVA. In a one-way ANOVA, also known as a single classification ANOVA, there is one measurement variable and one nominal variable. There is one measurement variable, one nominal variable. The null hypothesis stated for ANOVA is the statistical null hypothesis is that the means of the measurement variable are the same for the different categories of data. The alternative hypothesis is that they are not all the same. This is what one-way ANOVA definition. One-way ANOVA is used when comparing 2 or more group means and a continuous dependent variable. The independent t-test is a special case of the one-way ANOVA for situation where there are only 2 group means. Independent t-test we are using when there are only 2 group means. Here see ANOVA, one-way ANOVA for one independent variable and two-way ANOVA and ANOVA for 2 or more independent variables. One independent variable and 2 dependent variables we use ANOVA, and there are 2 independent variables and more than 2 independent variables and 2 dependent variables we use two-way ANOVA. So this is the basic of ANOVA. One-way ANOVA, only one independent categorical factor. Sales promotion, one-way ANOVA. This is the independent variable. This one factor can have multiple levels like heavy, medium and low levels, 3 levels. What is the independent variable? Sales promotion. The dependent variable, heavy, medium and low level, 3 factors. So we can go for one-way ANOVA. The n-way ANOVA means number of two-way ANOVA. There is one independent categorical factor, sales promotion and coupon level. Here 2 independent variables we have taken. And here each factor, like in the high, medium, low levels, you have to see each factor can have multiple factors. So that is known as two-way ANOVA. Then ANOVA is a covariance when one independent factor but consists both categorical and continuous. Categorical factor can have multiple levels. Now let us see chi-square test. The chi-square test is used as a non-parametric equivalent of t-test, and if the variable is falling under such a normal probability curve, then we can go for t-test. If the variable is non-parametric, it is not falling under parametric, it is non-parametric, we have to go for chi-square distribution. Before stepping into chi-square distribution, first I will give you examples, then we will come to these type of reading. Now let us see what is chi-square. So earlier I have already given you group A, group B, and score 60, 70, and by looking at the face value, we should not come to a conclusion that B is better than A. We have to work out t-test, and after the t-test, if we find that there is a difference, the value is higher than the table value, then we can interpret that there exists difference. After that only we can say that group B is better than A. But looking at the face value, we cannot say. Even suppose if the t-test value is lesser than the table value, we can assume that there is no difference between group A and B. That means, looking at the face value, 60 and 70 as average of A and B respectively, we cannot say that both B is better than A, because the t-test shows that there is no difference. So that is only applicable for probability, applicable for parametric test. Parametric test means the characteristics which fall under normal probability curve. Again, once again say, what are the characteristics? Parameters. So there are certain parameters which may fall under normal probability curve. There are certain parameters which will not fall under normal probability curve. I have given examples. You can take eating behavior, study habits, this habits. You can assume that these may fall under normal probability curve. But there are certain things which may not come under normal probability curve. We can take the example of number of pencils a person is having, or a number of pens a person is having. One person may have 1 or 2 pens, and some person may have 30 or 50 pens. That means it cannot be. We cannot give a assumption. We cannot give an assumption that normally each person will have two pens or 3 pens like that. We cannot give assumption. But normally we can say that eating behavior, we can say normally a person may have 2 to 3 idlis or 4 to 5 idlis only. We can say, but can we say that normally a person will have 4 or 5 pencil? If I have to say, I have to give pencil, and how many pencils I have to give to each student? Some person may like 2 pencils, some person may like 5 pencils or 10 pencils like that. So it may not fall under normal probability curve. It may not allow the parameters parameters cannot be assumed to be normally probable, normally non-distributed. In that case, we have to go for non-parametric equivalent of t-test. What is the non-parametric equivalent of t-test? Is chi-square test, where the t-test is, you see the degree of difference between 2 variables, but in chi-square it says whether one variable is independent or dependent on other factors. Let me show this example. Suppose the major wise, one student has business major, another one is liberal arts, another one is engineering. So 3 different major groups are there in a college, and you see number of cigarettes smoked per day. None. In business 6, because can we assume that the number of cigarettes will be placed under normal probability curve? This characteristic of number of smoking cigarettes cannot be placed under normal probability curve, because it varies from people to people. It is not a common behavior. This behavior is not falling under normal probability curve. We cannot assume that there may be very few people, there may be very less people, most of the people will smoke cigarettes. We cannot come to that assumption. Conclusion. That is why this example has been taken. Number of cigarettes smoked per day. Business people, none, 6. And you see 1 to 15, 60. And more than 15, 14 people. Total 80. Liberal arts, none, 14. And 1 to 15, 48. And more than 15, 8. and you see total 80. Engineering students, none, 610, and 1 to 15, 32, and more than 15, 8, and the total 40. And total, that we have to apply formula, and based on the value that we can interpret whether the cigarette smoking is dependent on major of a student or not, then we can say. If the value is less, we can say that cigarette smokes per day is not dependent on the measures they have taken. If it is more than that, we can say that the number of cigarette smoked per day is dependent on the major subject of students, that we can say. So this is the test to show you whether dependent or independent. So normally we are all confusing ourselves when data, before assuming that whether it is normally distributed or not, we apply chi-square also, we apply t-test also. I have seen number of theses, they are applying both chi-square and the t-test. What is the use? Because no need to use these two tests. These two tests are different. Cannot be used for the same data, because if the data is normally distributed, we have to go for t-test. If the data is not normally distributed, definitely you can go for chi-square test. Because there is a failure in identifying what type of data you are having. That is why again and again I am saying, before you get into your research topic, you see that variable, you study that variable, and you look at that variable, whether this variable can be placed on normal probability curve or not. Personality, normal probability curve, you can put. As study habits, you can put under normal probability curve. Eating habits, you can put under normal probability curve. And you can say the what is the interest, job interest, or so you just think and consult, and you think yourself, you logically build assumption. After that, you get into right type of statistical techniques. Now let us read. Let me read these chi-square slides for you, because I switched over to the example. Straight switch over to the example. For your sake, I read. Introduction. The chi-square test is one of the most commonly used non-parametric tests in which the sampling distribution of the test statistic is a chi-square distribution. When the null hypothesis is true, it was introduced by Carl Pearson as a test of association. There it is a test of significance, here it is a test of association. The Greek letter chi-squared is used to denote this test, x-squared is used to denote this test. It can be applied when there are few or no assumptions about the population parameter. When there are no assumptions, we cannot make any assumptions about population parameter. That time we can go for chi-square. Again I am saying, when we cannot make assumptions about population parameter, I have already given you example, the difference between eating behavior and the number of pencils or number of any number of things you can take. Number of, even the account holders you can take. So you cannot make assumptions. You cannot make any assumptions about the population parameters. That means that for that type of data, you have to go for chi-square test. It can be applied on categorical data or qualitative data using a contingency table used to evaluate unpaired, unrelated samples and proportions. Chi-square test is used to determine whether there is a significant difference between the expected frequencies and the observed frequencies in one or more categories. Do the number of individuals or objects that fall in each category differ significantly from the number you would expect? Is this difference between the expected and observed due to sampling error, or is it a real difference? Chi-square test of independence. The chi-square test of independence is probably the most frequently used hypothesis test in social sciences. In this exercise, we will use the chi-square test of independence to evaluate group differences when the test variable is nominal, dichotomous, ordinal, or group interval. The nominal and ordinal already we have seen comes under non-parametric test because it cannot be put under normal distribution. And the chi-square test of independence can be used for any variable, the group independent and the test variable dependent. Can be nominal, dichotomous, ordinal, or group interval. You see the group independent and the test variable dependent. When to use chi-square? Chi-square is used to examine differences between what you actually find in your study and what you expect to find. Look at the list of questions below. The answer is yes to each question. A chi-square test is appropriate. Are you trying to see if there is a difference between what you have found and what would be found in a random pattern? Is the data gathered organized into a set of categories? each category is the data displayed as frequencies, not percentages. Does the, because the number of cigarettes smoked, we can put frequency only, not percentage. We cannot put percentage. Does the total amount of data collected, observed data, add up to more than 20? Does the expected data for each category exceed 4? So suppose the category 4 exceed 4. In the earlier one, we say we found out none, 1 to 15, 15 to 30, like that. So it exceeds 4. Then steps of a chi-square test. To perform a chi-square test, we have to follow a set of steps. State the null hypothesis and the alternative hypothesis. Construct the contingency table for the data. Calculate the degrees of freedom. Construct the expected frequency table. Calculate x-squared calculate using your GDC or by hand in the project. Compare your x-squared value against the critical value given in an exam or given in the table. You could also compare the p-value against the significance level. State your conclusions. This is what the steps you have to follow for chi-square test. So I think this is what I have today for you, and I hope you would have enjoyed my class. And this is what I would like to say. And in this class, we have seen all these things. And in the discussion, if you ask questions, I may be able to explain to you. Okay. Suppose let me once again summarize what I have discussed, or give a just a recap of what we have discussed. And inferential data analysis we have discussed. And what is the inferential data analysis? In which we have discussed inferential data analysis. Statistics, descriptive statistics, and inferential statistics we discussed. Okay. Then, for example, once again. And then next is use and interpretation of data. And then the uses of why do we use the statistical technique. Then we discussed correlation. The correlation value ranges from -1 to +1, and there is a correlation, positive correlation, negative correlation, zero correlation, and proved estimation of correlation, and that these are all the things we discussed. Next, we discussed about t-test, and that is t-test. We discussed t-test. What is t-test? We discussed t-test, degrees of significant difference between two variables. That is t-test, and we discussed. And what is that? Z-test. Z-test, when the distribution is normally distributed, we can go for Z-test. Okay. Then we discuss what is that? ANOVA. When there are more than two means, we can go for analysis of variance, because when we are calculating difference for more than three variables, the one hypothesis may go wrong and may be rejected. We may commit type 1 error or type 2 error. That's why we, in order to avoid that, we go for ANOVA, analysis of variance. And in the last class, we discussed what is type 1 error and what is type 2 error. And if you are, I gave example also in the last class also. And there is you are rejecting the hypothesis, but that is true. That rejecting the, suppose there is no fight between you and your brother. This is the hypothesis. But getting into your home and you are saying that there is no fight, but you have rejected the hypothesis. This is type 1 error. Again, you are going with the same hypothesis. There is a fight between you and your brother, and you are going inside, and there is a fight, but you have not. But there is a fight, but you have not. But you have not rejected. We have rejected the hypothesis because we have not rejected the hypothesis. That is type 2 error, because there is a fight, but you are not rejected. Actually, you have to reject the hypothesis. That is type 2 error. The chances of doing type 1 error and type 2 error is more when we are calculating more than two means. And in order to avoid that, we go for ANOVA. And the chi-square test is used for non-parametric test equivalent of parametric t-test. So this is what we have today for you, and I hope I will meet you in the next class. And if you have any questions, you can ask me. Thank you so much for your patience listening. I hope you do enjoy my class.
Thank you, sir. Participants, if you have any questions, please put it on the chat box.
No questions?
Yes, sir.
No questions.
Shall I
Thank
propose
you.
the vote
Bye,
of thanks, sir?
Kannimoli, Indumadi, Deepali, Anju, Jayashree, Sita, all stating thank you only.
Yes, sir.
Didi, Pulshrestha. Also, thank you so much, sir. I hope you all have got what I have given. No? Is it clear about correlation t-test, z-test, and ANOVA and the chi-square test? So in the later part, when if you ask, we will go for correlation also for chi-square test and ANOVA. That we will. I am planning to do some SPSS analysis also for you in future. Once we completed the net preparatory course, we can plan for SPSS of t-test, SPSS of ANOVA, SPSS of correlation, etc. Regression and all. Thank you, Chaitanya, Ambika, Rajiv Vasan. Thank you so much. Thank you, students. Thank you.
Okay, shall I propose the vote of thanks, sir?
Okay. We can propose vote of thanks. If you are like our earlier one, here also we have to go for t-test.
Okay. A pleasant evening to one and all gathered here. First of all, I extend my most sincere thanks to Almighty God, and I thank our most Honorable Vice Chancellor, Registrar, Controller of Examination, Member Syndicate, all the head of the departments and assistant professors in Tamilnadu Teacher Education University, as well as one and all gathered over here. It's my privilege to have been asked to propose a vote of thanks on this occasion. A big thank you to my guide and resource person today's program, Dr.N.Ramakrishnan sir, Member Syndicate, Professor and Head, Department of Educational Technology in Tamilnadu Teacher Education University, for sharing your research knowledge and views on UGC NET set. Really inspired the participants, sir. Thank you so much. And my heartfelt thanks to all the participants for their active participation in this whole session. We thank you for being with us this evening. It's been really a great pleasure. Thanks a lot to one and all directly or indirectly involved in the program. We hope to see you again tomorrow. Thank you, everybody. Thank you, sir.
Thank you. Bye. Thank you. End the session.
Shall I wind up the session? Yeah, thank you, sir.
Yes.